All right, let's dive into an idea from the absolute edge of physics that might just change how you think about, well, pretty much everything. We're talking about time, reality, even the past itself.
And that brings us to the big question. Does the universe have a memory? And I don't mean that in some poetic, metaphorical sense. I mean in a very real, physical way. Is it possible that the universe never really forgets anything? That nothing is ever truly lost? Let's find out.
Okay, so right off the bat, we need to be super clear about what we mean by memory here. This isn't like our memory, the kind that fades and changes and gets things wrong. No, we're talking about something way deeper. Permanent physical imprints, information that gets encoded into the very fabric of reality and can never ever be erased.
Here's a great way to think about it. Picture the universe as this vast, endless shoreline. Now, everything that happens, a star exploding, a planet forming, you name it, is like a footprint in that sand. The waves might wash over it, it might fade, but the impression, that remains. The universe in its own way keeps a perfect record of everything.
But you might be wondering, how is that even possible? Well, the answer starts with one of the most powerful, absolutely unbreakable rules in all of physics. It's called the law of conservation of information. And this is our first major clue.
Now, to really get this, we've got to talk about what physicists mean when they say information. This isn't about data on a computer. It's the whole shebang, the complete, nitty-gritty description of a physical system. We're talking the position, the energy, the state of every single particle. It's basically the universe's ultimate blueprint for anything and everything.
Okay, so picture this. You have a book. Now, you burn it. The words, the chapters, the story, it all seems to have just vanished, right? Lost forever. But here's the thing. Physics says no way. The information isn't destroyed, it's just scrambled. The exact state of every single atom in the ash, the smoke, even the heat that was released, all of that is the book's original information, just in a chaotic, new, unreadable form.
And what this all boils down to is this one simple rule. The total amount of this physical information in a closed system, like, say, our entire universe, can never be created or destroyed. It can be rearranged, it can be scrambled, but it can never, ever be deleted. It's a fundamental constant.
For decades, though, there was one major suspect in the cosmos that seemed to be committing the perfect crime, just flagrantly breaking this unbreakable law. And that, my friends, brings us to the famous black hole paradox. Yep, black holes. These cosmic vacuum cleaners suck in everything: matter, energy, even light itself. And for the longest time, the thinking was that once anything crossed that event horizon, the point of no return, it and all its precious information was just gone, wiped from the universe, forever.
And look, this wasn't just some minor little puzzle. This was a huge problem. If black holes really did destroy information, it meant that one of the absolute pillars of quantum mechanics was just wrong. Physics was facing a serious, head-on contradiction. So you've got this epic showdown, right? In one corner, you have the unbreakable rule: information is eternal. And in the other corner, you have the ultimate cosmic shredding machine, a black hole. They couldn't both be right. Something had to give. So, how did physicists solve the case of the perfect cosmic crime? Well, it turns out they found the missing evidence not inside the black hole, but in the very fabric of the universe itself. You could call it spacetime's hidden ledger. It turns out black holes aren't destroyers, after all. They're more like cosmic vaults. The leading theories now suggest that the information of everything that falls in gets handled in one of two ways. It's either encoded on the black hole's surface, or it's slowly, very slowly leaked back into the universe as this faint radiation over trillions of years. So it's not gone, just stored in a really, really weird way.
And that right there solves the paradox. I mean, think about it. If the most extreme, most destructive object in the entire universe still has to preserve information, well then that rule must be truly universal. Nothing can erase the past.
So if the past isn't erased, where is it? Well, the wild part is, it's all around us. It's in the faint ripples of gravitational waves from stars that collided billions of years ago. It's in the subtle warp of space-time caused by the gravity of every single planet. It's even in the quantum jitters of what we call empty space. I absolutely love this analogy because it just captures the idea so perfectly. Space-time isn't just an empty stage for things to happen on. It is the recording medium.
Every single event that has ever happened has cut a groove into this cosmic record, and that recording is now a permanent part of the universe.
Okay, so this is where things get really mind-bending, because we're moving beyond pure physics and into some truly profound territory. If the past is never truly lost, what does that mean for how we understand reality, time, and history itself?
You know, we tend to think of time like a river, right? The past flows away behind us, gone forever. But physics suggests a completely different picture, a picture where time is just another dimension, like length or width, and all moments, past, present, and future, are connected. The past isn't gone, it's just another place in space-time.
And this is really the heart of it all. Every single event that has ever occurred, from the Big Bang to this very moment, still exists encoded in the current state of the universe. The Big Bang isn't just some distant memory. Its information is written into the cosmos we see today.
And this isn't just some cool thought experiment. This idea is a powerful key that helps unite our biggest theories of the universe. It forces us to completely rethink what it means for something to be gone, challenging our entire sense of destruction and finality. And maybe most beautifully, it reminds us that everything we do, everything that happens, leaves a permanent mark on the universe's grand, ongoing story.
And that leaves us with one last absolutely massive question to chew on. If every single moment of the past is permanently woven into the fabric of the present, what does that imply about the future? Could it be that it's also in some way already written in the grooves of that same cosmic record? Now that is something to think about.